Web applications are the lifeblood of modern business. They connect us, share information, and facilitate transactions. But this connectivity comes with a price: vulnerability to attack. Vulnerability assessment is the process of identifying and quantifying weaknesses in these systems. Think of it as a security checkup for your web application. Just like a doctor checks your vital signs, vulnerability assessments examine your application's defenses. They identify potential entry points for attackers, allowing you to fix them before they are exploited. Ignoring vulnerabilities is like leaving your front door unlocked, a risky proposition in the digital world. Without regular assessments, you're flying blind. Attackers are constantly evolving their tactics, finding new ways to exploit weaknesses. By proactively identifying and mitigating vulnerabilities, you build a more resilient and secure web application. This protects your data, your users, and your reputation. Vulnerability assessment isn't a one-time event, it's a continuous process. Think of it as a cycle with distinct stages, each playing a crucial role in maintaining a strong security posture. The first stage is planning and scoping. You define the scope of the assessment, identifying the web applications and systems to be tested. Next comes vulnerability discovery, where you use automated tools and manual techniques to uncover potential weaknesses. Once vulnerabilities are identified, analysis and prioritization are critical. Not all vulnerabilities are created equal. You need to determine the severity of each vulnerability and prioritize based on risk. Finally, you move to remediation and verification. This involves fixing the identified vulnerabilities and retesting to ensure they are effectively mitigated. Imagine trying to find a single spelling mistake in a library full of books. That's the challenge of identifying vulnerabilities in complex web applications. Thankfully, we have automated tools to help vulnerability scanners. These software tools automate the process of scanning web applications for known vulnerabilities. They act like digital detectives, crawling through your application's code, configurations, and network protocols. Think of them as specialized search engines, looking for specific patterns that indicate weaknesses. There are different types of vulnerability scanners, each with its strengths. Network-based scanners examine your application from an external perspective, simulating an attacker's approach. Web application scanners, on the other hand, focus on the application layer, analyzing code and data flow. Open source and commercial scanners offer various features and capabilities. Choosing the right tool depends on your specific needs and budget. Vulnerability scanners are powerful tools, but they have a limitation. They can only detect known vulnerabilities. Imagine a lock that no one knows exists, let alone how to pick. That's the challenge posed by zero-day vulnerabilities. These are software flaws unknown to the vendor and security researchers. They represent the unknown unknowns of the security world, making them particularly dangerous. Since no patch exists for a zero-day vulnerability, attackers can exploit it with impunity until it is discovered and fixed. The discovery of a zero-day vulnerability often makes headlines, as it did with the Heartbleed bug in 2014. This critical flaw in a widely used encryption library left millions of websites vulnerable to data theft. While not all zero-day vulnerabilities are as widespread or impactful as Heartbleed, their potential for damage is significant. Section 5. False positives. Noise in the system. Vulnerability scanners are essential tools, but they are not perfect. Sometimes they flag a potential vulnerability that turns out to be harmless. These are called false positives, the security equivalent of a false alarm. They create unnecessary work for security teams. This takes time and resources away from addressing real threats. Too many false positives can lead to alert fatigue. Section 6. CVE and CWE. Cataloging software weaknesses. Imagine a library where every book is categorized and indexed, making it easy to find the information you need. That's the idea behind CVE and CWE, standardized systems for cataloging software vulnerabilities and weaknesses. CVE stands for Common Vulnerabilities and Exposures. It's a dictionary of publicly disclosed vulnerabilities, each with a unique identifier, or CVE ID. Think of it as a fingerprint for a specific vulnerability. For example, CVE 2017-0144 refers to the Eternal Blue vulnerability exploited by the WannaCry ransomware. CWE, on the other hand, stands for Common Weakness Enumeration. It's a broader classification system that categorizes the underlying weaknesses that lead to vulnerabilities. For example, CWE 79 represents improper neutralization of input during web page generation, cross-site scripting. By understanding CWEs, developers can prevent entire classes of vulnerabilities. Section 7. CVSS. Measuring the severity of vulnerabilities. Not all vulnerabilities are created equal. Some are minor annoyances, while others can lead to catastrophic data breaches. CVSS stands for Common Vulnerability Scoring System. It assigns a score from 0 to 10 to prioritize remediation efforts. Section 8. Threat Modeling with Stride and Dread. Imagine building a house without considering potential risks, like fire, theft, or natural disasters. That's what it's like to develop software without threat modeling, analyzing potential threats and vulnerabilities early in the design phase. Stride and Dread are two popular threat modeling frameworks. Stride stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. It helps identify threats based on these 6 categories. Dread, on the other hand, stands for damage potential, reproducibility, exploitability, affected users, and discoverability. It uses a scoring system to assess the risk associated with each identified threat. By using these frameworks, development teams can proactively address security concerns, building more resilient and secure applications. Section 9. Secure Source Code Review. Finding bugs before they bite. Imagine a book editor meticulously reviewing a manuscript for errors before publication. That's the essence of Secure Source Code Review, a critical process for identifying and fixing vulnerabilities in software code. It involves examining the source code of an application, looking for security flaws, logic errors, and insecure coding practices. Think of it as a security audit for your code, performed by trained security professionals. Secure code review can be performed manually or with the assistance of automated tools. Static analysis tools scan the code without executing it, looking for patterns indicative of vulnerabilities. Dynamic analysis tools, on the other hand, analyze the code while it's running, identifying vulnerabilities that only manifest during execution. Section 10. Mastering Terminology for a Secure Web. In the ever-evolving landscape of web application security, knowledge is power. Understanding the terminology is like learning the language of cybersecurity. It allows you to communicate effectively with security professionals, interpret vulnerability reports, and make informed decisions about your application's security. By mastering these terms, you gain a deeper understanding of the threats and vulnerabilities facing web applications. This empowers you to implement effective security measures, reducing your risk of compromise. Remember, a secure web application is not an accident. It's the result of informed decisions and proactive measures. By staying informed and embracing a security-first mindset, you can build and maintain web applications that are both functional and secure. In the digital world, knowledge is your best defense.